All right, hello everybody. It's the top of the hour, but we don't yet have in the room Rowan Mahey, Conrad Kobrook, or there's Raphael, at least one of our presenters for today, and Conrad. Let's wait a few more minutes and see if Rowan turns up before we dive in. In the meantime, as ever, we do need a note taker for today's session. So if we have any volunteers, a note taker would be greatly appreciated. Okay, Rowan just joined the room, so I think we can at least plow on through the chair slides before we get into today's actual substance. So first, as usual, we need everybody to note well the note well, in particular IETF's policies on intellectual property and the code of conduct. For today's agenda, we have the chair slides which we're covering right now. Then Rowan's going to discuss abuse reporting, and then we're going to continue discussing metadata privacy. Rowan, do you want to bash the agenda?
It's okay if Conrad goes before me on the metadata privacy.
Okay, sounds good. In that case, right, on the context of metadata privacy, we'll get some updates on me, that's three me's, from Raphael and or Conrad, and then back to Rowan for pseudonymous privacy flows. Anything else on the agenda? Conrad, go ahead.
Okay, camera doesn't seem to work. Oh, no, there it is. Yeah, I have to apologize. I wasn't really aware that I was scheduled as to present something on the meeting. I'm happy to talk about the email I sent a couple of hours ago and maybe facilitate the discussion on the individual points. But yeah, there's no real update on me. It's still in the same state as we presented a few meetings ago. So it's not much to say, but yeah, as Ron just said, we should just discuss what's in the email. Concretely, that's the requirements, assumptions, and the threat model. But yeah,
that's fine. We can make use of the time that we have here to have some real-time conversations on the record. But if we end up not having too much to do, then we can just adjourn today's session early. Okay. So in the interest of keeping things moving today, I'll go ahead and take some notes. So then you'll forgive me if I lag a bit on moving slides along or whatever else because I'm typing elsewhere. And with that, I think we're on to, do I have the slides? Yes, I do. Rowan May, the floor is yours.
Hello, hello. Okay. So next slide, please. This is all about PR number 83 on the, which I'll put a link in the chat here. But this has been around for since a little bit since, you know, basically just as we were starting just before IETF 120. So I just kind of wanted to go back over what I think the requirements are for anti-abuse, and this doesn't mean that these are the only requirements, but I think all of these things are requirements. So the first thing is that the receiver of a message can report it as allegedly abusive to the hub provider. And we had some discussion at IETF about the last IETF about why to the hub, and I think this is you know, consistent with the Mimi model, where the hub knows things that other providers should not know, particularly in light of metadata privacy. So it's because it knows the policy of the room. So if you had you know, sort of you know, crude language or sexually explicit images or things like that, that might be perfectly okay in one room, but not in another. And so the policy of the room would dictate whether some messages are considered abuse or not. Likewise, you know, like unsolicited commercial things might be okay in some contexts, but definitely not in most. And then we've got all the messages going through the hub. And, you know, this sort of relies on that. The mechanism that I propose relies on that, but the fact is that right now, you know, a sender sends a message through the hub, but the like the local provider, for example, doesn't even know necessarily like who the other participants are. So a receiver might not be known at all to the local provider. Okay, so the receiver of a message reporting it as allegedly abusive, it would presumably send the plain text of the allegedly abusive message so that the evaluator can actually check this. I'm just going to add as an aside here that DKG asked if this process could be sort of, you know, done by like a third moderator service. It certainly could. I'm not going to talk about that at great length, but basically, using the directory service for Mimi protocol, you could point the reporting to some third party, you know, to some other URI that's managed by some other third party, and then the two things that would be required for that third party would be that third party have access to the that they know about the room, what the room policy is, and that they have access to the hub's franking key. So those are both reasonable things to do. Okay, the next sort of the second big bullet point here, the hub can't read the messages, the content of messages unless they're reported. That should go without saying, but I thought it was worth repeating here. And then next, the receiver can't attribute a bogus abusive message to a sender. And then likewise, a sender can't deny a message that they sent, or can't substitute it with some other message. Oh, sorry, this sub-bullet point here, that was just an error. Sorry, just ignore that, please. Okay, so I think that those are the top level, you know, the top level requirements that I could see. And there may be some additional requirements, for example, like we may decide that it's valuable to have a standardized way for a hub to report, like, hey, I got the following abuse, collected the following suspicious activity to be able to send to the sender's provider. But I wanted to focus on this chunk of functionality first, and I think that this other stuff coming later doesn't really isn't prevented by the mechanism that I proposed. Does anybody have any questions or comments about the requirements? Awesome.
I'll go ahead. Okay, so the hub in this design is the recipient of plain text like abusive messages, and then does something with them. So suppose though that the recipient that's trying to report a message as objectionable is not a subscriber of the conversations hub, but is a member of a follower, like a follower provider. Do we need some mechanism by which subscribers of follower providers can like discover the endpoint on the hub at which abusive content gets sent?
Sorry.
What I'm concerned about is the risk of like, if I'm a subscriber to a follower hub, and I'm reporting abusive messages, I think I don't want to do so to my follower provider because I don't want to expose the content to the follower. Does that make sense? Like I need to do it directly to the hub.
Okay. Yeah. All right. Let me just look at what's in here. So the report. Okay. So the abusive messages. So that would be. Yeah. Okay. So that's currently an issue right now. So if we wanted to add that as a requirement, I think that would be fairly straightforward, and I think that's a reasonable requirement. And next people who talk, please feel free to chime in.
Go ahead, Raphael.
Okay, thanks. Yeah, I have a couple of questions actually. Just to confirm, the penultimate line saying hub can enforce policy based on real user identities, that was by mistake, right?
Yes.
Okay. So yeah, I think in general, I agree that the hub should be the one, being the arbitrator and receiving the reports, because that's in line, just as you said, it's in line with the architecture in general, and doing it differently would probably be much more complicated, and that could potentially be delegated. I cannot think of a particular problem with that, but who knows, maybe we'll find some. The one question I have is, to what extent do we also want to surface the action of the offending user to the home server of that user, if at all?
Yeah. So my philosophy for this was that I imagine that for a typical peering agreement between a large messaging provider and anyone else, that there's likely to be, pages and pages of SLA text about how they, what they need to report and how and to whom. And so my initial reaction was that if initially that there is not a standardized way to report this between two providers, that I was sort of okay with that, and that if it was a requirement, that we could obviously define one.
Okay, because I think it would raise a number of questions of what that second step in the reporting would actually mean and what it would look like. Is it exactly the same one as the first one, where you essentially reveal the clear text of the message, etc., and Also, what guarantees do you have at that point, etc. What rules apply? And yeah, and then the following question, and the last one for now, is, and maybe that's going to be on the next slides, I don't know, is what should the consequences be on the hub specifically? Like, are we looking at a ban, or what did you have in mind?
Yeah, I mean, I had this listed as there's basically evidence and remedies. And so the remedies, I think, I listed remedies that can be taken in a room, like preventing somebody from sending a message, temporarily, kicking them, banning them, and then sort of moving up from there, telling the, possibly via a non-Mimi message, telling the provider, hey, I just banned this, please ban everybody from this identity, which could be a pseudonym. And then from there, maybe the local provider has a way of gating the gating future pseudonyms issuance on the sort of reputation of existing pseudonyms, or maybe it has a break glass way of linking pseudonyms to a real identity. Maybe it uses homomorphic encryption or searchable encryption to sum the spamminess from multiple pseudonyms. I want to, I think that the number of remedies is large, and that in some places people will want to have a big hammer. But the reason that I focused on this particular part is that this is something that needs to be, it needs to end up at the hub, for the hub to look at the policy, and then from there we can kind of decide what we want to do and whether that's something we need to standardize.
Okay, yeah, thanks. I mean, for the privacy preserving variant, I think there are some options, but once we are more clear about what the actual requirements are, I think we can take a look at that point. Thanks. I'm going to yield the floor.
Can you hear me okay?
Yeah, Alyssa.
Okay. So you may have answered this earlier, but I want to make sure I understand that all of the constraints around what any given pair of providers is willing to accept from each other as far as abuse reports, or like what any given individual provider requires of interoperating providers in terms of abuse reports, or limits from other providers, i.e. like if there's a provider who only ever wants to get the last 5 messages of someone who's being reported for abuse or something like that, that all of that is to be defined outside of the protocol through policy. Am I understanding that correctly?
So I would say that the policy of the room would determine what things are, what kind of messages or behavior are allowed or not allowed. And I would expect that the reporting, figuring out like how many messages would be sent or whatever, that's probably set by the hub. But then what you do with that information, what the hub does with that information, and like maybe the hub is doing this using automated means, or maybe it's doing manual means, or maybe it's doing a combination where for some things that are in a gray area, it doesn't have like a strong a strong confidence about using an automated means that it sends it to a user. Maybe it has a suspension, sort of like
right.
suspend this
I'm
policy.
not talking about what the hub does with the report. What I'm talking about is if there's no limits on this, then like in the extreme case, by virtue of me as a user of provider B, agreeing to join a room with a user on provider A, anybody else in that room could potentially report all of my messages to provider A, who is not my provider, and send them in clear text because they're doing an abuse report. And now every message I've sent to anybody in this room is available to this provider with whom I have no relationship because they've been abuse reported. Now, my understanding of how this works in the siloed case that we have today, the non-interoperable case, is actually that you, like, I think in WhatsApp, for example, like you can only report the last 5 messages. Like there's some constraints around this in
Okay. I see what you mean.
so that somebody else can't use the abuse reporting mechanism in order to just decrypt every message that you've ever sent and share it with Meta Platforms Inc.
So I'm gonna point out that with a WhatsApp client, that you could go and I could scroll up in my history and I could report, from message 25 to message 30, and then from message 20 to 25. So you can only do 5 at a time in the UI, but you could theoretically, expose all of the messages that you've ever had with somebody in WhatsApp. The other thing is that if someone wants to expose messages to the hub or anyone else, they can just, take a picture, take a screenshot, copy, paste, whatever, right? So we can't prevent a user from doing that in other ways. But I think that the goal is to have something which works in a way that's fairly similar to how the WhatsApp reporting mechanism works now.
Okay, but in terms of what the hub establishes as its either requirements or limitations on what it's willing to accept from users of other providers, it sounds like none of that is going to be expressed in protocol that we standardize in this working group. It sounds like all of that is going to be expressed in SLA. And what we are working on here is like the single primitive that allows a user to report 1 or more messages, and that's it. And that's all we're going to provide.
Okay. Well, my intention was that, so I talked a little bit about room policy, and my intention was for us to define a fairly robust set of room policies, and that this would certainly be the kind of thing that we could put in there, and we could put guardrails on that. When I spoke about the SLA, I really meant about communication between the hub and the sender's provider.
I see. So when you say room policy, that includes both like what kind of conduct is allowed in this room and also how to report abuse in this room.
Yeah, and like whether abuse and like here is a privacy policy for reported content, and here's a link to a document that you can read, and here is how to contact a moderator to if you want to like if any of that information is available, like stick that in the policy document.
Okay, I understand. Thanks.
Okay, so besides the protocol requirements that we're discussing here, I'm thinking about like the explicit, let's say, operational requirements on a Mimi provider that wants to be able to receive abuse report requirements. And like off the top of my head, there's 2 things. Like we've talked about moderators implying sort of possibly a function staffed by human beings that would review these abuse reports and make decisions about them. So does that mean that like a provider that does that mean that providers wishing to act as hubs for rooms are required to staff and operate a moderation function? And then past that, we're talking about here that reporting a message as objectionable requires disclosing the plain text of the message to the hub. I suspect right enough, like in many cases, the plain text of the message will be content that the hub doesn't really want, or like might need to invent or build some like, some special mechanisms to carefully handle like what might be hazardous material. So would this be, both of these strike me as like expensive and complex things that a messaging provider might have to build out. So is this something that like every participating meme provider would have to take on, or do we imagine that like only those providers wishing to act as hubs would have to do it? Or would it be that like, maybe a hub isn't allowed to host rooms with certain policies unless it can provide like certain moderation functions? Do you see what I'm getting at?
Yeah. Okay. So I kind of lost track of like the first question versus the second question, but I would say that in terms of so I think that any sort of consumer grade IM system would probably need to have some way to deal with this, but maybe, like if the laws in the country where it's hosted were suitable, maybe there's a country somewhere where people can go and run a system where, even like, death threats and hate speech and things like that are allowed. If that's the case, then they wouldn't need to support the reporting mechanism at all. They could just say this room doesn't have any reporting. But I think in the consumer case, I think pretty much any consumer provider is going to have this mechanism for their own internal thing, and the policies could be very flexible about what you actually need to be able to do, and whether, I imagine that for some things people might be able to get away with entirely automated reporting, but I think that there's quite a lot of push for legislation that says that providers need to be able to at least have an appeal policy for, this wasn't actually abusive or whatever. I don't think that. So, I don't think that being a hub in this way changes anything from whether you offered this functionality internally or not. It just changes whether you can, in a standardized way, report this information from a non-local user. Did I answer your second question?
It does. Well, yeah. I mean, it wasn't so much two questions as like two examples of complex requirements for a provider, but there was really just one question about, do we expect to provide do we expect to require providers to implement all this stuff? And it sounds like the answer is no, but if a provider does not implement these things, it may not be able to host certain rooms, or right?
I mean, I would put it a different way. I would say the software, if we said the software must implement this thing, and then you can, by policy, you can turn it off. That might be a tree, the tree falling in the woods kind of a thing. But in terms of the operational requirements for the provider, I would say no, the provider does not have to. We're not writing a spec that says providers must turn on this feature.
Yeah, that makes sense to me. Thanks. Raphael, go ahead. Unless.
Yeah. So just want to get back to what you said initially, Tim, about handling that stuff. So I think perhaps what could be within scope for Mimi would be to specify how the reporting works exactly, and also in a way that it is actually encrypted to the hub, maybe beyond just using TLS, so that it becomes easier on the hub to build a proprietary system that handles that sensitive information, so that you can specify how the key management works, etc. Like, I don't know, I'm shooting from the hip here, but using HPKE to chem stuff to the hub rather than using TLS to then send plain text. And I'm going back to the last point. I think we should not make it a requirement that you can only be a hub if you actually have a staffed, team, or like our team working on that stuff. Otherwise, I think we'd miss the point, especially for smaller providers who want to be Mimi compatible, but couldn't afford to do any moderation with actual people behind it. Yeah, that's it.
Okay. All right. Okay, so I think we had a nice, healthy discussion about the requirements here. Unless somebody else has something else to add, I'd say let's go on to the next slide, please. Okay, so the mechanism described in the PR really consists of two parts. So the first part is about franking a message that is submitted. And so franking is like the moral equivalent of like you send a letter to somebody and you put it in a sealed envelope, and then the post office receives it and they put a stamp on it that said, we got this, this was received at a particular time and I definitely saw this envelope. And then the envelope is forwarded on. So the properties of this mirror the requirements. Like the contents of whatever is in the envelope, the post office doesn't see, they don't know about, but if somebody presents the envelope, the sender can't deny that they sent this envelope. And in this case, the contents of the message is also bound to the envelope. So very briefly, the way this works is that the sender creates a unique per message secret. It encodes this secret, its identity and the room ID inside the message. And if you were using pseudonyms, this would be the pseudonym identity here, right? Whatever the identity is that you were known by when you send. It then generates a franking tag covering the message. So since the message includes the key, the identity, and the room ID, so the franking tag covers all of those things. It puts this in the additional authenticated data inside of the MLS private message. So the hub can see the franking tag, but can't see any other aspect of the message. And since this is a hash, it doesn't reveal anything sensitive. So the hub then sees this tag and then encrypts a hash of that tag, the sender's URI, the room URI, and the timestamp. And it takes this and forwards it on to the receiver. So the encryption of that stuff, that becomes the frank. So then when the receiver gets this, it decrypts the message, and then it sees the tag, and it regenerates the tag. And if the tag doesn't match the message, it says, wait a minute, this was not a valid, the sender was lying about the contents of this message. This is totally bogus, and throws the message away. Otherwise, it knows that this, it has basically proof that the sender sent this particular message. Any questions here before I go on?
Looks like I beat Raphael to the punch. Okay, you describe how the hub encrypts hash the tag and some metadata, and then the receiver verifies, I guess means decrypts that tag. How is what key does the hub use for this, and how is that distributed to, well, I guess first off, who does that key go to? Is it just all of the members of a room, or is it also all the other hubs? And then, how is that key circulated?
Okay, so there are two keys. So the sender generates a unique per message, I'll call it a secret. So that's put inside the message. So basically anybody who receives, anybody in the room can see that secret. And that's how they verify that the franking tag created by the sender is actually authentic. Then there is the key that the hub uses, and that is only, that is basically private to the hub, or in the case if we had a third-party moderator service or something like that, the third-party moderator service would need would need that key in order to be able to verify the franks generated by the hub, or would need some API that they could use to verify franks.
Sorry, so Ben, that means what, the hub has like some API by which it exposes the key used?
It doesn't expose, the
or
hub
public
doesn't
key.
expose the key. So
I
the
must be
hub
confused.
just has a key. It's an HMAC, right? So it's like it takes the key and it concatenates it with the data and it does a hash. And it just needs to validate it. It just needs to do the same thing again with the same key. So it has like, it might have in a database, like I used this key from on the following timestamps, you know, from this range of timestamps to this range of timestamps or whatever, something like that.
I understand. So the receiver of the message never like does anything with the HMAC or whatever it is applied by the hub. It's just the hub can later check its own HMAC to sort of prove to itself that the message did ever transit through itself.
Yeah. So the receiver gets the thing that the receiver does with the frank that comes from the server is it gives it back to the server if it reports. So it's just for the hub to verify, yeah, this message, I saw this message.
I understand now. Thank you.
Raphael.
Yeah, my question was going to be along the same lines. I'm still not entirely sure what encrypting the hash means here. Did you mean HMAC by that, or?
It's HMAC, yeah.
So, I mean, if anything, HMAC would be a signature, but even that is a bit of a stretch. But so, yeah, I think that sounds similar to, you know, what has been used in the past. The question is, are you proposing to write up a concrete protocol here, or was that just a summary to give us an idea?
Yeah, this is just a summary of like, you know, at a very high level for people to understand what the message flow or the data flow. But it's written already in the PR. And it is effectively the Facebook franking scheme with 2 changes. So the biggest change is that it was possible with the original Facebook franking scheme for the sender to generate invisible salamanders because there was no commitment. And the way that this gets commitment, I believe this is correct, is that the franking tag, because it's in the AAV, it's committed to in the message. The other change is that because Facebook is doing this in a single system, it doesn't need to hide the sender URI, forwarding it to another server in its system. So if, in this case, we need to make sure that a follower doesn't see the sender's identity. And so there's a small change made where we send a hash of something instead, a hash that of the sender URI mixed with something instead of the sender URI.
Okay. Yeah, I'm just wondering what the right way is to go forward with this. One way would be to come up with a specification of either an existing protocol or a slightly modified one, like you just said.
Mm-hmm.
And we probably need to do that. But it would also be nice on a more abstract level to formulate what guarantees we want, you know, what party to have. Exactly what you just said, you know, you don't want the follower to see the identity and stuff like that. So some abstract requirements at that level.
Yeah.
That would be useful.
Okay. Conrad?
Yeah, sorry, I'm still having trouble understanding the construction here. So I do understand that the hub has a key and, you know, computes some MAC over the message and some metadata so that when it receives it later, it can verify, oh yeah, this was actually, you know, this passed me by and I created this tag. What is the purpose of what the sender does here? That's not super clear to me.
Well, so in order for the sender generates this franking tag so that it's basically committing to this particular tag is bound to is bound to this particular message. So even though the hub can't see the contents of the message, the hub sees the franking tag and can issue a frank that is specific to that franking tag. Meanwhile, the receiver uses the franking tag to verify that the sender can't cheat and assert a totally different message later, or just claim that they didn't send that message.
But can you describe the attack again? Sorry, I'm still having trouble wrapping my head around this.
Okay, so an attack from the sender would be the sender constructs one message and sends it, and later claims that they sent a totally different message. They say, "No, I didn't send a message that said, I'm gonna come to your house and kill you. I sent this message that says I'm going to come to your house and give you flowers." And so the franking tag means that the hub is going to put a frank that covers this particular franking tag, which was committed to by the sender. It also means that the receiver, when it gets the message and decrypts it, it can make sure that message is the same message as the one matches the tag that it received. So that's the first attack. And then the second attack is the receiver making up a message that the sender allegedly sent that they didn't actually send. And so if the receiver doesn't have a frank from the hub with a corresponding franking tag, then the hub will never believe the receiver saying, "Here is, I got this message."
Okay, I think I'll have to look up so this is kind of, you're trying to implement what's done in this invisible salamander paper.
Well, this is the there are several papers listed in the references here. So it describes, let's see, so Grubbs 2017, and the Facebook Messenger, secret conversations paper. So secret conversations describes the Facebook Messenger franking mechanism. Grubbs describes the problem with describes the invisible salamanders problem specific to the Facebook mechanism, which requires committing the tag. This solves the committing tag problem. I believe that the mechanism that I propose solves that problem. It's described briefly in the text of the PR. And then there's also the other change that I alluded to is that the context that the hub includes in its frank includes the sender URI, but it has to use a hash of that instead of the URI, and send the hash of the URI instead of the actual URI, so that the followers don't know who sent the message.
Okay, thanks. I'm still having trouble to see which part of the information is now bound where and how it all comes together in the end. But thanks. I'll take a look at the PR and the reference material.
Yeah, sure.
So yeah, there's probably a good reason why it's done that way. And I think that, like, in a naive approach, it would be enough if the hub franked the whole ciphertext that it sees. But the problem is that at the receiver's end, the ciphertext is going to be thrown away. It's not going to keep the ciphertext around typically, but then it wants to report stuff later, and now it needs something, that the hub has still seen, which is not the ciphertext, and that's probably why we need this tag.
Yeah. And in addition, this has a nice side effect that it allows us to, if I have 3 different clients and I replace my phone with a new client, and I back up my message history and restore it, I can back it up with the frank and the franking tag, and then I can still report a message later, even after I switch devices.
Right. I mean, for what it's worth, I think it's a viable approach to, take Facebook's approach here, incorporate the changes we know that are necessary, and then make sure that enough people look at it.
Yeah.
Especially the relevant people.
Yeah, and the reason that I started with that first slide is mainly because I wanted to make sure that we were largely on the same page as to the requirements before I start barking up the wrong tree.
Right. But again, if we can abstract away the requirements we have for the specific protocol here, without immediately proposing a solution to it, this might also leave some room to come up with an alternative protocol that might make things even better by giving us even more guarantees, whatever they are. So I wouldn't want to close that door entirely either.
Yeah. So as a totally a totally separate thing, I think that one of the additional concerns that I had about other mechanisms that have been described in the literature is how heavyweight they were and whether they required additional round trips. So having an additional round trip between, so like Hecate was brought up by Deirdre, so having an extra round trip between the client through their local provider to the hub and back before you can send any message, that seems undesirable to me. If we can
that's exactly what should go in the requirements list for the protocol. Is that you have a tolerable number of round trips. Now that we know that Hecate is a bit heavy on that side. And then we can debate, whether we agree or not with that particular requirement. And if we do, then we look at a potential solution. All right. Thanks.
Thank you.
On the topic of enumerating requirements, I think I'd add that we wouldn't want, I think you and Raphael were just discussing how in this design, the clients are not required to indefinitely store the ciphertext, which is definitely an important property. We also would not want hubs to have to store like the full or even partial history of even ciphertext, because I think that would be extremely expensive for them. Now, one question, okay, so we're talking about like writing up requirements more thoroughly, which I guess we like doing a lot in this working group. But the PR that we're discussing here is on MIMI protocol, which is a document that describes like concrete mechanisms. Sorry, what I'm getting at is where would we want to write down these requirements? Like in another document or in MIMI protocol or where? That might be a question for Raphael. Go ahead.
I mean, I do what we always do, start with a draft. And then as it matures, we decide if we want to merge it with another document. But it's separate enough to, be its own draft, I think. Deafening silence.
Yeah, everybody's rushing to the mic to volunteer to write that draft, I think.
I think the default choice is unless somebody else is hopping up and down, I'm probably going to have to write it. So you can sense my enthusiasm, but I also think that it's, I also agree that Raphael is right, is that that's probably a good default choice. So I'd be happy to hear otherwise, but if not, I can also do that.
Go for it, Ron. We'll be happily criticizing it afterwards.
Bonus. Awesome. Comments are better than no comments, right? So I'll take it.
Okay. Do you want to do the last slide, Ron?
Oh yeah. Yeah, and I was actually like in real time kind of writing up some of these additional requirements here, but okay, yeah. So then the reporting, so that's all described in what would become section 5.4, and there's a new section 5.4.1 on the message franking mechanism for when you submit a message, and then there would be a new section 5.9 which is the abuse reporting mechanism. And so this is a new endpoint where the receiver sends a report to the hub. It contains the decrypted message in the frank. The hub can verify that it franked this particular message from the alleged sender. And the hub can verify that the message presented by the reporter, since it never had the plain text before, but now it can take that plain text and it can see that it matches the message sent by the sender because the sender franking tag matches. So anyway, I think that we had already kind of covered most of this already, but yeah, that's my last slide. I'm just writing up some of the additional requirements.
I'm going to ask a question that I probably should know the answer to, but do we allow rooms to move across providers in Mimi at the moment?
We currently have no mechanism to do that.
Okay, I would think not, because what occurs to me is that this mechanism relies upon the hub being able to verify that it franked the message by checking like the HMAC, which means that, yeah. So anyway, so I think that this mechanism rules out room migration unless you do something else complicated so that like the new hub provider could verify stuff. But we don't need to get into that because we don't want to support migrating rooms. But I think that there are implications for like the lifetime of the hub franking key here, in that I think it has to outlive a given room. Like you wouldn't.
No, it can be. So it can be, like the way this is implemented in practice is that it can be rotated. It's just that like you keep it around, and you may even keep it in cold storage, right? Because you don't need to respond immediately to an abuse request. If somebody says, "Hey, this guy sent me an abusive message a year ago," well, it might, if you have to go and get that message from some external system to go and verify the tag, that maybe that's not a big deal. But like the classic way of doing this would be if I rotate it, every day or every hour, as long as I keep a copy of that and I say like, all right, that's for messages that I sent between these two timestamp values, then you're good.
Yeah, that makes sense. And I guess this doesn't imply any requirements about like whether there's a per room abuse, whatever key, or if there's a global one across the entire hub, because I guess the client doing right, that's all opaque inside of the hub provider. Okay, never mind. Thank you.
Exactly. Yeah. Raphael.
Yeah, going back exactly to Tim's point, I think he beat me to it again on the mic. I need to be quicker. So I think it's definitely within scope to specify some aspects of the key management on the hub. I don't know what exactly. Some of it is definitely internal and therefore can be proprietary, but maybe what could transpire is like a key ID or something to, for it to be part of the franking, so that the hub later understands which key it used at the time and stuff like that. So yeah, that's within scope. And coming back to Tim's question about moving a conversation or moving a group from one hub to another, it's still a little bit unclear. We proposed a draft for that early on. It's still there. It's called Mimi Portability. It's fairly basic. But then at some meeting, and I don't remember which one, a while ago, it seems like we ruled out that functionality from the scope, but I'm not sure if we ever fully agreed on it and if that's in writing. So as a side point, I think it would be great to look into that again. I don't know if anyone remembers anything more specific.
I do not. Okay. So I've got I have no idea if this is going to come out as gobbledygook or not, but let's see if this works. Oh yeah, no, that's really ugly. Okay, I can just read the additional requirements that I added here. So I added before the second to last bullet point. If you want to go to the second slide, maybe, Tim. So I added the following. Follow-us servers do not learn the sender of any message. The receiving client does not need to store the ciphertext indefinitely to report a message. So this is consistent with like MLS key schedule deletion. If you've gone through several commits, like after your second, third, or fourth something commit, you delete the cipher, you delete the keys, the keying material. The hubs don't need to store the ciphertext to verify that they received a particular message. And then not especially heavy to implement for a client or server. And like one specific case of this is that adding extra round trips before sending a message would be especially painful for clients. So those are the four things that I added to my local copy of these slides, as well as deleting the spurious thing that I mentioned earlier. Anybody have something to say about any of those? Okay. So there.
Okay, so I think that's it for abuse reporting today, right?
Yep. Okay, take it away, Conrad.
Yeah, there you go, Conrad. If you want to just chat about me. Thanks.
Yeah, I mean, me and Rowan's draft that he sent around. So while reading through your draft, Rowan, I noticed a couple of, I tried to compare oh, sorry. It's just the mic turned on. So one of the things, maybe just go through the differences and then kind of see. Oh, can people hear me?
We can now, but you were perhaps your first paragraph was chopped up.
Okay. Having internet problems all day, so that might be it. Sorry about that if that's the case. So yeah, my main concern, not sure what got lost here. So my main concern was figuring out the differences between Rowan, between your draft and the me stuff, and to figure out if we're aligned in more general terms. The first one was the requirements. So for example, in your flows, you have this pattern where you have pseudonyms or like someone can request a pseudonym and then they use it and then they reveal the connection between the pseudonym and the identity kind of actively as an application message. And whereas in the me stuff, it's kind of the connection is facilitated by distributing key material, and then whoever has the key material, like in the context of a particular group, it's always scoped to a group, can then figure out the identity on their own. So it's kind of a passive linking versus active linking, and I guess both have their advantages and disadvantages. So the one requiring some key distribution to begin with, and the other one requiring the person who is revealing their connection to be online. So I guess my question then is, what is the requirement here? Do we prefer having some restriction in terms of having this extra key material to manage, or do we want this active reveal action at the cost of having this extra round trip? So for example, if I understood the flow correctly, if Alice establishes a connection with Bob, then Alice has to be online to initiate the connection establishment. Bob has to be online to accept it, and then Alice has to come online again to actually tell Bob who she really is. Is that correct?
Sorry, I kind of
Understanding
lost
of the
track
flow?
of which of the three of my example flows you were talking
Yeah.
about. But
Okay, sorry, the connection establishment flow. So
oh yeah. So that one is
Alice,
that's designed so that like, yeah, Alice sends something to Bob, and yeah, there's going to be, she needs to wait for Bob to come online, but I don't think she needs to wait for Bob to come on. If Bob has a regular key package, she could reveal her identity to Bob right away without an extra round trip, without an extra cycle of online offline handling. But yeah, so Alice sends something, Bob has to come online, and then before they can, Bob can then like sort of start the. I think that's pretty representative of a standard connection flow. It's just that you end up with an extra room, but Alice can reveal directly in the room with Bob her real identity, and the thing that would be needed there is Alice needs to be able to identify that this is sort of like Bob has key packages and permissions for rooms that are sort of like special kinds of rooms that Bob uses that they use for connection purposes.
So, but just to understand correctly, but this connection establishment doesn't allow Bob to, identify Alice in the context of other rooms. So if Alice and Bob have a connection now, and now Bob invites Alice to a room where Alice wants to be pseudonymous. She doesn't want to use her real identity because she doesn't want the hub to see her real identity, but maybe she wants to see the folks in the new room to see her real identity. So how would that work? Does Bob then somehow use this information that Alice has sent in the application message to, does Bob reuse the pseudonym in the new room and then reveal the connection, or how does that work?
So I mean, I think that you would use the pseudonym identity in all of the MLS messages, and then inside of in a private message inside the room, each person would reveal or not reveal their own identity as appropriate.
But is that reveal persisted? So if Alice reveals her identity in a room using an application message, and then someone else joins the room, how does that person learn who Alice is?
Yeah, that's an issue. I think if you didn't, in the absence of like a message history mechanism, you would need to have that revelation again. And so maybe new clients would query, or I don't know. It's a good question.
Okay. Because this is kind of one of the issues we struggled with in our Mimi design. But Raphael, sorry.
Yeah, I just want to interject one more question here. So doesn't this introduce a problem with the kind of asynchronicity that we actually want in messaging? Meaning you join a room and say if somebody added you, the usual way with a commit and an add proposal. But as you join, you immediately want to know exactly who's in the room because you're about to send a message and you want to know who you're going to send it to. So if you have to wait for everybody to send you an application message in order to understand who the people in the room are, then you can't, it's not asynchronous anymore. It becomes synchronous. Is that correct? That was a question to Rowan. Yeah.
Sorry, I had a little bit of momentary network glitch on my side.
Should I repeat?
If you could do that quickly, that'd be great. I'm sorry.
Yeah, no worries. So my question is, don't we lose asynchronicity because if the identity reveal happens over application messages, and say Alice adds Bob to a group, and then Bob cannot send a message until everybody has sent him their identity over an application message, then it becomes synchronous. Like Bob has to wait for everybody to have come online once. And in a larger group chat, of course, that could take a while.
If that's what Bob requires, if Bob requires to see the actual identity before joining or before sending a message, then I'd say yes. For the use cases that I envisioned, I didn't really see that as. I saw it more as valuable for a particular sender of messages. So I was imagining where you join a large group and everyone is synonymous, but in order to sort of make, Alice wants to make her point more relevant or more forceful or more personal, and when she sends her message, she also reveals, she can also include a disclosure or reveal her identity in that message. And so everybody who's seen that message and is in the group at that time also sees her real identity. And they can use that as like, oh, well, yeah, this is somebody who knows what they're talking about because she's Alice in this context. So that's kind of what I imagined. But I can see how the use case you described is also like an equally important use case where people just want to be like, they want to know exactly who's in the group and for real before they send anything, before they participate anyway.
Yeah, I mean, I was going to say that we should try and lose as little as functionality as possible, and so that would be bad.
Alyssa?
Yeah, I guess I agree with Raphael's last comment. Like, it seems to me that the very common case is where people want to know who they're talking to. And it's like very much a corner case or more of this kind of broadcast kind of scenario where it's like, I don't really know who's in here, but I'm going to start posting. And the point of all of this is to protect the metadata from the providers, not from the users. So I don't know. It feels like we need to optimize for the common case.
Yeah, I think if I might jump in here, not using the queue, but so I guess what we try to aim for with the Mimimi stuff is to keep the pseudonymity entirely on the kind of infrastructure level, so it doesn't touch the feature space, the user space at all. The users are not, it's transparent to the users if there's a pseudonymity on the server or not. The users always see one another with their real identities. Of course, you can, selectively not do that in groups. That should be possible. Like, we haven't really thought that through, but I don't see why that shouldn't work. But I think thinking of it that way, or first creating a situation where we can provide all these the metadata protection only at the infrastructure level, and then use it selectively if we want on the user level, and generally try to have almost like as close to the same user experience as possible as you would have without the pseudonyms. That was the goal, at least.
Yes, completely agree. That seems like the right set of priorities to me.
Okay.
Yeah, and just following up on that, I mean, the whole idea behind Mimimi was to enable that particular flow as well, meaning you get invited, you join a room, you know immediately who's in it as a client, essentially. Yeah, and from the past comparisons with Mimimi compared to the standard version of the Mimimi protocol, we didn't miss too many things. The one UX requirement that we haven't really solved is that if you consider a multi-client user account, then you have to pass on some secrets as you onboard a new device to your account, essentially. So it's not as easy anymore to just sign up from a new device. But yeah, this might also a problem we can solve going forward.
Rowan, you're still in the queue.
Hey, yeah. So, like hearing you guys talk about it, I agree that the sort of Alyssa's, common case where everybody wants to know who they're talking to, that does seem like a more less of a violation of least surprise, kind of argument. I'm cool with that. The other thing that I like, the way that I've been thinking about this though is where privacy disclosure is. I've been thinking about selective disclosure, and particularly like selective disclosure JOTs and COTs. And so the idea here is that it's much more fine-grained. So I might join a room where one of the things that I disclose in the room is I disclose that I'm over 21. And I disclose the country that I'm living in, but I don't disclose my name. And so the expectation in a room is like, I'm disclosing that I'm allowed to be discussing certain topics, or that, or maybe I'm disclosing, much more anonymized information than a real identity. So just so you guys know what the background might, like where I'm coming from with this, I agree that that's a more fringy use case than what you guys are discussing, but I also want to make sure that we can still do those kinds of things, because I think there's a lot of power and value in being able to do those kind of selective disclosures that are property based or claim based, and not necessarily just your name or your real your master identity URI, say.
No, I agree. I think that's very valuable, and as is the the propagation of this pseudonymity properties from the kind of infrastructure layer, protecting it from the hub, but also propagating it to the user level, protecting it, protecting your identity from other users, be it like completely or pseudonymizing yourself completely, or by revealing your like only parts of your identity. So the question is, how should we move forward? So one thing that we could do is, at least from the Mimimi perspective, right now the document is really meant as a kind of really rough, giving you the idea conceptually of what we wanted to do. There's some flows in there and some basic mechanisms. What we could do is flesh out the concentrate on the identity reveal part, which is we have these credentials where there's a encrypted there's an encrypted part which hides your real identity, and only the group members have the decryption keys to that. And we could extend the Mimimi document to go a bit more into detail there, and then if then we could use that as basis for discussion and see if that's sufficient for the use cases where we want to extend pseudonymity to the quote-unquote user land, or instead of having real identities in these encrypted credentials, we could also have these partially attesting credentials. I'd have to take a look at how that technically works, but at least in the Mimimi stuff, it's all signatures. So I don't think that shouldn't be. I don't think it shouldn't be impossible. No, that's one negation too many. I think it should be possible. Sorry. Okay, so if there are no objections, then I think we'd be happy to do that until the next interim. That should be doable. Another thing I want to talk about, and I don't think that's neither in the Mimimi stuff nor in your document, Rohan, is kind of, or actually no, I think you actually talk about this in your document. So what are the assumptions we make about the client server protocol on the follower side of things? And so, for example, what does fan out look like? Now we have pseudonyms. So with real identities, we would just take a message, fan it out to the a follower and say, hey, this message is for X. How does that work now? Do we just hand the pseudonym to do the same for the pseudonym, or do we also have what we consider in our design encrypting something that can be decrypted by the follower server, and then it has some queuing information in it or some proprietary information that's proprietary relative to the client to a server protocol on the follower side of things? Is that something that folks have thought about? Or Ron, I'd be interested to hear your take on this.
A little bit. Yeah. Britta, why don't you just say what you just wrote?
Oh, I'm multitasking in the background, so I, just disrupting the chat by throwing it out curveballs into space here. But verifiable credentials could be a way if you're looking at selective disclosure. The caveat that I haven't thought through with that is if we are wanting to get into a pure pseudonym use, because obviously you wouldn't get a true anonymity. So there's definitely trade-offs there, but it's just something that maybe we want to keep in the back pocket as we're continuing discussion.
And yeah, and for my use case, like I did envision a system where you could get very cheap credentials, like per pseudonym, selective disclosure credentials. So you could disclose, in order to join a room, you could disclose like, that you're not a child, and you could disclose, that you belong to a particular provider, but not disclose like anything else. And then you could disclose more information inside the room as you wish. But, yeah.
Okay. Yeah,
I have one more question regarding that. Do we know that this sort of selective disclosure is non-interactive, or would that be interactive somehow?
It's not interactive.
Okay, thanks.
Yeah. So, I mean, to answer, sorry, I'm going to put myself in the queue. So to answer and Ori thankfully helpfully added another a link to something useful here in the chat. I was going to say, in answer to Conrad's question about like what can we do, I think that putting a little bit more flesh around the, explaining a little more like tutorial around how the revealing identity works in Mimimi, I think that'd be very valuable. And I promise to read it more thoroughly if it has that in it. I've so far read Mimimi.
Okay, sounds good. Then I guess my last point was, what are folks' thoughts on mitigating traffic analysis threats? And I can maybe say 2 words in terms of what we did with Mimimi, or general thoughts on designing a system. Is that, so we try to kind of, say that that's kind of orthogonal to what we're doing, in terms of that people can use Tor or Mixnet or something along those lines to actually, counter that threat, because it's really hard to actually mitigate against traffic analysis. At least that's my impression as a non-expert on that field. But I think there are some things that we have to do to enable it, and that's at least build the protocols in such a way that there's no, you don't do any batch querying. So, for example, if I have 5 pseudonyms and I want to send, I guess I want to send a message, because retrieving messages is part of the local client server protocol. I want to send messages, then I don't send a batch query that sends messages, using all the pseudonyms at once or something. That's something that reveals that these pseudonyms are indeed linked. So I think that was our only, way of enabling the use of, or at least not breaking the potential use of a mitigating measure against traffic analysis. Any more thoughts on this?
Do you mind clarifying that a little bit more? I didn't quite catch the connection between what you're discussing on the Tor mixnets and a batch query of pseudonyms.
Right. Okay, sorry, I should maybe clarify a bit. So the idea was to at least give people the option to put in place measures to prevent the provider from just looking at its own, incoming traffic, or maybe a bit weaker, like an observer on the network, to somehow correlate individual pseudonyms, or really, link pseudonyms to identities just by observing the traffic, again, either from the network, from kind of a network adversary point of view, or from the hub provider point of view. So that if you were using like a mixnet that properly, adds, delay to certain messages, and of course, assuming that you have a certain amount of traffic coming to the hub that actually allows you to, blend in with the masses in terms of your individual queries, then you could actually, then the protocol that we build actually allows people, doesn't defeat those measures by design. For, again, like if you had a batch query that somehow linked more than like multiple pseudonyms, then even if you use Tor to make that query, the server would always see, there's a batch query coming in. The batch query is relating these 5 pseudonyms. Of course they're linked wherever they're coming from. They're using Tor, but those 5 pseudonyms are linked to, are linked together. And so the biggest issue there was with queuing, again, which is not part of the server-to-server protocol that we're designing here, but part of the client-server protocol on the local level, where if you had multiple pseudonyms, you could, in theory, have multiple queues, but then clients, for efficiency reasons, would always want to, collect all messages in all of their queues at once, due to the constraints of, current mobile operating systems. And that would, of course, by having this kind of batch retrieve query, would link all these different queues, and that would kind of allow the queuing server to observe that these queues are indeed linked. And so if you wanted to hide that, you would have to at least allow, collecting the queues individually, and then using a Tor or a mixnet to do that, and then hopefully not allowing the local server to correlate, to relate these queues. I've talked quite a bit now. Was that understandable? Did that make sense?
I think I have a little bit better idea of what you're going for there. I'm not sure I quite see the whole picture, but yeah, thanks.
Okay, as I'm talking, I'm kind of convincing myself that it's not such a big problem on the server-to-server front of things. But yeah, we don't have to do it in this discussion. It's not a super pressing topic. I'll try to think a bit more about it and have some slides ready for the next interim. Thanks for the suggestion, Rowan. Yeah, I think that was pretty much all I wanted to talk about. It was mostly about the kind of, when to link identities and how to, when to link pseudonyms to identities and how that happens. I think we had that discussion, and yeah, we have an action item to improve the Mimimi doc at that front. So I'm happy with the discussion. Thanks, everyone.
All right, thanks, Conrad. Final thing on the agenda today is Rowan. You want to talk to us about pseudonymous privacy flows?
Yeah, so I mean, I was just gonna, I just wanted to really show the 3 flows. I didn't prepare any slides, but if Tim, if you could just share the document and just sort of scroll to each of the 3 flows. that'd be super useful. And I also don't, if people need time to digest this, more time to digest this, I'm okay with ending a bit early. I just kind of felt like this was a bit of an introduction. So if you scroll to section 3.1, so basically everybody gets their own pseudonyms, and they store key packages, not just for their regular identities, but for their pseudonyms as well. So that's that first little piece of ladder diagram, and then scrolling down to the next one. So here, Alice creates a room. Alice adds Alice's other clients. Alice queries Bob's real identity. So this might be like a whistleblower looking for the name of somebody, looking for a contact to try to connect to somebody at the Guardian newspaper, right? And so they send a query for Bob's real identity, and they get back an internal identifier for Bob, request a key package for Bob, and then they and this is a special, like in this case, this is like a special kind of connection key package that's somehow labeled. So then Alice adds Bob to this room. Bob gets a notification, and there's basically waiting for Bob is a welcome with the tree, and then Alice can go ahead and send a first message that basically says, I want to connect to you. Here's my real identity, or some aspects of my real identity, and here are key packages that you can use if you want to have further conversation. This is how you can get a hold of me. And the key thing here is that those key packages are with a second pseudonym of Alice's. So they're not linked to the first pseudonym. So Bob accepts and actually creates this second thing. There's no correlation that the hub can see or any followers can see between Alice's identity and Bob's. They don't see that this is connected to Bob's real identity. So scrolling down a little bit. So here Bob actually creates a room and basically does a commit, adding presumably Bob's other clients, and then the Alice's clients that have those key packages. And then Bob says, hi, talk to me, tell me more. So this has, as since this was brought up earlier by Raphael, so this requires the asynchronicity of Alice sends this connection message and then needs to wait for Bob to reply, but there's no additional sort of round trips that are required in order to set this up. One potential problem here is that if Bob waits a long time, it's possible that the key packages that Alice sent are no longer valid, that the lifetime has expired on those. But if Bob really wanted to talk to Alice, that's probably not a big deal. Okay. Can we scroll down to the 3.2, please?
Let's hear from Melissa first.
Yeah, just my typical ill-informed question. So that basically means communication consent is required under all circumstances when the users are using these pseudonyms. You can never send a message until Bob accepts.
So I think the thing about the connection request is that if you identify a special type of, Bob has this special type of connection request key package, is that it would be understood that you could send a single message, which would be sort of your introductory message, and then further messages would just be thrown on the floor, and you'll be if you try to use it for a regular chat, Bob is going to just remove himself and throw any messages that received away.
Okay. Well, that's no different from the non-pseudonymous case, where that's exactly how you would implement communications consent anyway.
Yeah.
Yeah. Okay.
So, and not an ill-informed question, obviously. Okay, so scrolling down to the join link flow. So in this one here, Alice creates a room. Alice adds Alice's other clients, creates a join link, and then this assumes that there's some out-of-band mechanism for getting this to Bob. And this could be that Alice and Bob are in person. Maybe there's, they share a QR code. Maybe, writes half of it in one, Village Voice newspaper, classified ad, and another in a Craigslist classified ad. And, Bob knows to combine them. Maybe there's a trusted third party. If it's a trusted third party, the trusted third party could totally become an active attacker. That's accepted. But then, Bob basically uses this join link from one of Bob's pseudonyms. Alice created the room with one of Alice's pseudonyms. Bob uses the join link, and then you're in a room where Bob and Alice are using their pseudonyms, and Bob and Alice can, reveal each other selectively. This has the problem that Bob doesn't necessarily know right away who all is in this room, right? Bob can share, and even Alice doesn't know when Bob joins if it's really Bob, although the join link might be single use or might have some other restrictions on it that make that more likely. Okay. Okay, Tim, would you scroll down to the third one, please? Okay, so in the third one, I call this like a knock, but basically, this is if I have a big group. So let's say that I have a, LGBT in Uganda group. And so there is, maybe there's a web page that has, here is the group. But then there's also an associated knock room, or this is the way that you get access to the system. And so Kathy uses a pseudonym to connect to the knock room and says, yeah, hi, I'd like to join, and this is my, here's my real identity, and here's some key packages that you can use to add me to the real room. Now in this case, since Kathy knows the room ID of the real room, the key packages could be restricted to only work in the real room, the key packages that Kathy sends. And then as well, like the pseudonym that Kathy would be using for those key packages, that's up to Kathy. So that would be a second pseudonym as well. And so then at some point a moderator or administrator of the target room decides that Kathy is legit and wants to add her to this room, then they would go ahead and commit those key packages, commit with add using the key packages that Kathy provided, and welcome her into the group. Conrad.
So with this knock room flow, what I was wondering is, why do you, so this knock room is an MLS group, like it's a room in and of itself, is that correct?
Mm-hmm.
So, but really the only thing you want to do here is send a key package to the moderators for consideration, no?
Yeah, but you may not know who all the moderators are, but the moderators might be anonymous. So by reputation, you might trust that, okay, like I have friends who have told me about this group. Like I trust that the group has a bunch of trustworthy people. And I'm gonna plead my case to join the room.
Okay, because this notion that there's a knock room with with the moderators in it, but also lots of other people in it, and then Kathy would send her key package that contains a real identity. to this
So-
room and then rely
Yeah,
on it
so-
not being received by the others. That seems a bit weird to me in the context that this is meant to be, used by marginalized communities and stuff, that where you want to have a really robust threat model.
Mhm.
So I guess my question is, why not just have a group with the moderators in it and then export an HPKE key, and then Alice can send that to the HPKE key so that all the moderators can use it. I can read it, something like that. That's what I would have expected here.
If you want to write up that flow, that's great. I mean, I think that the problem that you described, I think there are mitigations described there, and if you don't think that those mitigations are good enough, then I would say, like, please, maybe write 1 or 2 sentences about why you don't think that those are good, and those, you may be totally right. But I think that there, I did take some steps to try to make some mitigations there. So if you think that that's
Okay.
not sufficient for a marginalized community, like, I'll respect your opinion, but I do want to see a little bit more detail about that, please.
Sure. I can write an email or a PR or something.
Perfect. Yeah.
Just wanted to make sure I understand correctly.
Yeah.
Okay. Thanks.
Okay. So that was pretty much. Oh, sorry. Go ahead, Tim.
Thanks. Is the knock room one-to-one with the real room, or do you create like one knock room per client, I suppose, that wants to join the real room?
So the knock room is like a persistent room, but the idea is that somebody wants to join, they send their message basically saying, I want to join, and then they're immediately removed. They remove themselves or they're removed by the system. Also, that members of the moderators get to read messages, and I guess they could send messages if that was important, but that everybody else has the policy where they can't read any of the messages in the room. They're never forwarded any of the messages in the room. So that's the mitigation that I described.
Got it. Thank you.
So anyway, that's all I got. I did describe a little bit about these sort of some selective disclosure things in section 4. I described how you could do that using X509, even though I don't think that's a good idea. How you could do that with JSON Web Tokens, or selective disclosure JSON Web Tokens, or CBOR Web Tokens, or selective disclosure CBOR Web Tokens, or verifiable credentials, or verifiable presentations, or whatever. But I think that if somebody's interested in that, like, just please read the section. It's quite short. Yes, I totally agree about X509. It's more like I wanted to bring up that you could do it, and just because you can do a thing doesn't mean you should.
Okay. Anything else from your end, Rowan, on pseudonyms?
No, I'm actually, so even though we didn't come up with many conclusions today, I think we had a really very fruitful discussion on both topics, and I'm quite pleased. And it was very, very interactive and cordial, and I'm really pleased with how the interim went today.
I think we did successfully agree on X509 being bad, which is an important a sign of a credible working group. Okay. So we have about 20 minutes left on the clock. If anybody has anything else we'd like to discuss, like on this current pseudonymity topic, go ahead, Raphael.
So yeah, on the mailing list, I proposed that we could discuss attachments, but I think that didn't make it into the agenda bashing earlier. So I'm happy to go through it in the same way that Rowan just went through that draft. If folks are interested. Mainly, the idea is just to get the discussion started, not to.
Fine with me.
Yeah, sorry. I thought I put that in the agenda, but I'm apparently losing my mind. So.
No worries.
Yeah, sounds fine to me. Is there a document you'd like to have shared?
Yeah, that's
Or-
the Mimi attachment document. Do you want me to share a link or?
If you want to speak to it, you could share your own screen.
So I'll just put the link in the chat here. I can try and share my screen. I've not been very successful with that in the past. Let me see.
Give it a try, and then I'll do it if it doesn't
Yeah.
work out. Grant screen.
All right. Can everybody see it?
I think you want to zoom in a bit, but we can't see it. Actually, you want to zoom in a lot.
Is that better? Yeah. Okay.
Definitely better, but yeah, keep going.
Okay. Okay, I think this should be big enough.
That's good.
Yep, let's go.
All right, so admittedly, we wrote that like a year ago and I haven't looked at it since. So recently there was a discussion about how we do access control and how we do proxying. So this document doesn't really go into that much at this point. And also just to zoom out, actually, the approach here is the same one we discussed earlier. This is just a draft to discuss ideas, and then we see if we're going to merge it with the Mimi protocol document. So I think what we do here is that we assume essentially that attachments, which are essentially files, get uploaded to the hub, so that the hub is in charge of them, and acts essentially as storage to start with, but can also enforce quotas, for example. And so that has the benefit that things are somewhat simple in that the sending client, like the uploader, knows exactly where to upload the attachment, and then everybody else who's part of the group can actually download it from the hub, and we avoid this sort of proxying and stuff. But again, this is just a naive approach at this point. Might not be good enough. So what we have here is essentially a message we define between the client and the hub to send a request to upload a document, and then the hub would reply with a token essentially in order to do that. So this references an early version of Rowan's content format draft, which might be completely outdated by now. But so the question is how exactly we advertise the attachment in an application message. And there's a little bit of fluidity actually, in the sense that at least at Wire that was the case, and maybe that's also the case for other messengers. If attachments are small enough, sometimes you want to actually have them as an application message, meaning they go into the typical messaging queue, as opposed to having a large binary blob that has a completely different mechanism in how it's uploaded and downloaded, etc. So yeah, that's just one side aspect of it all. Maybe folks have opinions about that. And that slightly would influence, yeah, the cryptography part. So receiving attachment is somewhat similar in that there is a download attachment request, simply because the storage might not, be available directly as part of the endpoints of the hub, and that gives us a degree of separation there if that's what we want. And okay, deletion is probably. Yeah.
Right, before we move on, I want to respond to your point about sufficiently small attachments possibly being delivered as application messages. Is this something that you envision as being, say, a per room policy item? Because I feel like, in particular, the threshold of like size might be dependent upon the type of internet connection that the membership of a particular room has. Like, people with faster connections will be more willing to deliver larger attachments like in band, right?
Yeah, excellent question. So I think in general, I don't know if we talked about this ever before, but there should be some agreement as to how big a message can actually be, like a content message. I don't remember, Rowan, if you specified that in the content format draft, but it's, if not, we definitely need that. Rowan, go ahead.
I'm going to go back to my familiar refrain of that's up to the policy of the hub, how big what kind of attachments you're allowed, how big, like what content types, et cetera, and the in terms of the external part, CBOR struct, it's a UINT 64 as the max size.
Right. Yeah. So definitely agree that should be part of the policy. Like from experience, messages that go into message queues, they have to be small because typically these architectures are not designed to handle large messages. Because especially mobile clients, and especially on iOS, they have to download messages in the background. And they have very limited time to do so, and internet connections might be bad, so you don't want them to choke on larger messages. So this is typically a requirement that messages should be small. So even though we might have some flexibility in the policy, we should be really careful to, maybe even define an upper bound that makes sense. Ron, go ahead.
I mean, I would be hesitant to say that the protocol should give a must level thing here, but I mean, I think it would be perfectly reasonable for us to say, yeah, like things like thumbnails or whatever, like you could send those in line, but if it's over a certain size, we recommend sending it using a out of band attachment mechanism.
Okay. I think, again, from experience, I think we should be a little more assertive here, simply because systems might just break if you give them large messages. Like they might just not be designed to handle that at all.
I mean, if you send a message that's bigger than the policy, so like a hub can just say like, my policy is this. Like, if you try to send a message that's bigger than that, it's not that's going to be illegal. So I'm not
sure. Yeah.
How this is any different, right?
So I mean, the hub can immediately enforce that, but the problem is, for example, that a follower also needs to agree with it. Like the architecture on a follower needs to be able to ingest whatever it gets from the hub. Yeah,
and I think that there are going to be SLAs between providers, and these operational issues. I think providers are going to come up with largely very similar. They're going to come to consensus on very similar stuff. I don't think that we need to specify this in the protocol, personally.
Right, but we might have some language nonetheless. Because the practical effect might be that if the policy on a hub is that you can send super large messages, then in practice nobody's ever going to federate with that hub because it just doesn't work. So at least we might give some, strong guidance that it's absolutely preferable to only deal with small messages and exclude larger ones. But okay, maybe we can set that aside for now. So let's say that the maximum size of a message is X, and that is specified in the policy. I think we have that agreement. And now the fluidity I was referring to is that now all of a sudden you have the choice, potentially, if the protocol supports that, to say, oh, I have a really small thumbnail that is actually much smaller than X. Why don't I include it in the message? Which is perfectly fine with a policy. But what that means is that it's a little different in that you have this little container now as part of the content format. Yeah, I guess that sort of summarizes what the fluidity was about. Does that answer your question, Tim, from earlier? Because we got a little distracted.
It does. Thank you.
Okay. Yeah, so deleting attachments, this is very vague at this point. Who is allowed to do that? So yeah, it refers to a policy. I guess the policy should govern who can actually upload attachments and delete them. And this couldn't be arbitrarily complex because it's directly enforced by the hub. Right, so the idea here is that attachments are actually bound to a specific MLS group, simply because, well, and again, a room actually, simply because that gives us, a natural limit in which we can operate. So the naive approach would be that if you want to forward an attachment from one room to another, you would have to download it and then re-upload it in the other room. But then possibly if we're not happy with that, if we want the forward operation to be more efficient, we could see if we can just, as long as it's on the same hub, we could just also move it from one room to another directly to save some payload. But that's subject to discussion if we need that. I'm also not entirely sure what others do in that respect. So maybe we should also align with what's the best practice there. So yeah, if anyone has questions, just interrupt me because I don't see the queue. My browser tab. So yeah, I think the part that is a little more explicit is how the encryption works here. And so the idea was, of course, to use the MLS group exporter to get some key material, because why not? And so we want to reuse what the MLS group gives us here, and then we have the primitives at our disposal, like IDF, hash, AAD, and expand with label. And so we can walk through the steps of encrypting it. So in order to get some commitment, we hash the plaintext of the attachment first. And then we generate a nonce. We also set a context, which we're going to use for the exporter. And so that is essentially specific to the sender inside the group so that we can avoid collisions that way. So I think we might send several or upload several attachments per epoch from the same sender, and this is why we also have a nonce. So we use the MLS exporter here with that information. And finally, we get the attachment secret, which we can use in order to compute the final nonce key pair that we're going to use for AAD. yeah. Any questions about that part, Rowan?
Yeah. So what do you see as the pros and cons of using an exporter secret versus the sort of industry standard of the sender encrypts with their own nods and then sends the nods to everyone in the group?
So I think just, sampling random data is only as good as the random number generator of that client. So since we potentially have a lot of really good entropy from the MLS group, we thought it would make a lot of sense to reuse that because it absolutely comes for free at that point. So it's a bit, it's like defense in depth, if you will.
Okay, but I guess my question is do you envision that the encryption key is still sent so that somebody can consulting their history gets access to this, or is that they really need to go and export the secret at the moment that they receive a message in order to get the receiver key?
Yeah, good question. I think what we had in the beginning is that if we only send the token, which is essentially just an identifier, and the nonce and the hash, that allows everybody who's part of the group to recalculate the key. So we don't send the key here explicitly because the whole idea is that you reconstruct the key to make sure that you inject the entropy from the MLS group. If you literally send the key, you don't have that guarantee anymore. I get your point. If you want to have history, then just having that message is not good enough at that point. Like you would also have to conserve the output of the MLS exporter.
Yeah. Sorry to jump in here. Yeah, I just wanted to say essentially what you just said, Raphael. If we and we haven't really talked about any concrete proposals for history syncing or scroll back or any of that stuff. But I assume it's not going to be the matrix style where we keep around the actual ciphertext of the messages and then folks are decrypting that. So there's going to be some sort of something that's not necessarily what's actually sent, or it doesn't necessarily have to be what was actually sent, but you can actually inject stuff in there. And so in that case, I would just inject a message. Like if you wanted to back up your local history to export it to someone else or to store it locally, you would just inject the exported secret there, which shouldn't be a problem, I think. Yeah.
I mean, for what it's worth, I think this is a bit of a departure from other stuff, like other messages, say text messages, where you can just keep the plain text and then forward that to a new client or whatever. So this definitely forces you to keep around more than strictly the content of the message. But that would be doable, right? All you have to do is save the output of the exporter when you exported it for the first time. Yeah, I mean, that brought us to the end of the document, and I think we're also at the end of the hour now, pretty much. So I guess we have like either time for one more question or some nice closing remarks from Tim.
Yeah, sorry, just watching, see if anybody gets in the queue. But no, looks like we are done for today. We are just about at the end of our time. I don't really have much in the way of closing remarks, except to thank everyone for joining us today for the interim, and a reminder that we have another one of these scheduled. Let's see, looking at the data tracker now. Looks like it's set for September 4th at it's 9 a.m. To 11 a.m. Pacific time. Please do consult the data tracker for accurate scheduling information in your time zone. We don't currently have anything on the agenda for that. So if anybody wants to talk about anything, please contact the chairs. What is it? mimi-chairs@ietf.org, and we'd be happy to reserve some time for you. One other thing is that not at that interim, but I believe at the following one, which will be September 18th, we want to get back to discussing discovery requirements. And in particular, we'd like to invite everybody in the working group to review the discovery requirement draft that's currently uploaded on the data tracker. And please send all your feedback to the authors on the mailing list. We'd like, in anticipation of some more discussion of those documents and possibly adoption in the course of future interims. But that's it for today. So I'll see you all. Actually, I will not be around for the next interim. Alyssa will be running that one without me. But otherwise, we'll see you all on the list and out there. Thanks, everybody.
Thanks, everybody.
Thank you. Bye.
Thank you.
Thank you.